So welcome back students. In last session we finished the exercise 22A. So in this session we will do exercise number 22B of trigonometry 9th grade. So straight away we'll go to questions. All the concepts which are there I will try to solve within the sum itself. So let's try to do first sum. The first sum says we have been given a figure, a triangle which looks like this. This is x, this is 2, this is 1, this is y. You have to find the value of y. You have to find value of sin x. You have to find value of sec x minus tan x into sec x plus tan x. Okay. So let's try to do it. So to find y, we simply apply Pythagoras theorem. So Pythagoras theorem says this square plus this square is 2 square. So 1 plus y square is 4. Y square will be 4 minus 1. So y square is 3. So y is root 3. So we found y. Now they are saying find the value of sin x. So sin x is opposite side upon hypotenuse. So that is y upon 2. Y was root 3 upon 2. Next they are asking us to find out the value of sec x minus tan x into sec x plus tan x. Right? So let's try to do what is sec x. Sec x is hypotenuse upon adjacent, which is 2 upon 1. Tan x is opposite upon adjacent, which is root 3 upon 1. Again sec x is 2 upon 1 and tan x is root 3 upon 1. So this becomes 2 minus root 3 into 2 plus root 3. A minus b into a plus b. It's a square minus b square, which is 4 minus 3, which is 1. Quickly let us move to the next sum. Okay. Next sum is given. Let us try to draw a figure and understand what they've asked. So we have been given a figure like this. This is 90 degrees. Something like this. This is x degrees. This is y degrees. This is 6 units. This is 8 units. This is 17 units. So we are supposed to find sin x cos y, 3 tan x minus 2 tan y, 2 sin y plus 4 cos y. So let us first try to find, we are asked to find cos y, 3 tan x minus 2 sin y plus 4 cos y. So these are the three things that we are supposed to do. These are the three things we are supposed to find out. So let's see how we do it. So for sin x is basically opposite. Let us name the sides. It is not given. It's okay. I will name it A, B, C, and D. So sin x is opposite side because we'll have to consider this right angle triangle ABC for finding sin x. A, B, C. So sin x is opposite upon hypotenuse. So sin x will be opposite is 8, hypotenuse is 70. This is done. Cos y. So cos y we will consider this triangle ABD. ABD. This is a right angle triangle ABD. So cos y is adjacent upon hypotenuse. So now we do not know AD. So let's apply Pythagoras theorem in triangle ABD. So that will be 6 square plus 8 square is AD square. 36 plus 64 is AD square. 100 is AD square. So AD is square root of 100. So AD is 10. So this is 10. Now I can find out cos y degrees. is adjacent, which is BD, upon hypotenuse, which is AD. That is 6 upon 10, which we can cancel out 3 and 5. So 3 upon 5. So this also we found out. Next is 3 tan x, 3 tan x minus 2 cos y, 2 sin y plus 4 cos y. So 3 tan x, for tan x we'll consider this right angle triangle ABC opposite upon uh, uh, adjacent, but we do not know the value of CD. That also we'll have to find out. So let's try to do Pythagoras theorem on ABC triangle. So that will be 8 square plus BC square is 17 square. So BC square will become 8 square I will take on that side. So BC square will become 289 minus 64, which is 225. So BC will become square root of 225, which is 15. So this entire thing became 15. This is 6. So the balance CD will be 9. So now I can find out tan x. So tan x is going to be AB upon BC opposite upon adjacent, which is 8 upon 15. So 8 upon 15 minus 2 sin y. Sin y is opposite upon hypotenuse in this triangle. Sin y is opposite upon hypotenuse, 8 by 10 plus 4 cos y. Cos y is adjacent upon hypotenuse, which is 6 by 10. This will get cut 5. This will get cut 5, 2 and 5. So 8 by 5 minus 8 by 5 will become 0, and 12 by 5 is the answer. So the value is 12 by 5. Okay. Next type. Let's try the next sum. Okay. In the diagram given below, triangle ABC is a right angle triangle at B, and BD is perpendicular to AC. Find cos of DBC and cot of DBA. Let's try to understand and solve this problem. This is 90 degrees and we're drawing a perpendicular from here. This is B and this is D. So this also is 90 degrees. This is C. This is A. This is 5 centimeters. This is 12 centimeters. I have to find out cos of angle DBC and cot of angle DBA. These are the two things. So I have to find out cos of DBC. DBC, which means let me name this as X. And DBA. So this. So if this entire angle is 90 and I've taken this as X, so the balance would be 90 minus X. Yes or no? Now, if this entire angle B is 90, correct? And this angle is 90 minus X. Okay, I'll talk about angle BD, triangle BDA. If this angle is 90 minus X and this angle is 90, which means this angle will be again X, because sum of all these three angles have to be 180 degrees. Now again in this triangle, if this is 90 and this is X in triangle ABC, this is 90 and this is X, so this will be 90 minus X. Is it clear? Which means angle DBC, which is X, angle DBC is equals to angle CAB? Yes or not? So if angle DBC is same as angle CAB, which means if I have to remove cos of angle DBC, it will be same as removing cos of angle CAB. Yes or no? So cos of angle CAB in this triangle ABC, cos of angle CAB. So I have to remove cos of this angle. So cos of this angle is uh, adjacent upon hypotenuse. So it will be AB upon AC. AB is 12. I do not know AC, but in triangle ABC I can use Pythagoras theorem, which means AB square plus BC square equals to AC square to find AC. So 12 square plus 5 square is AC square. 144 plus 25 is AC square. So 169 is AC square, which means AC is 13. So I got this value, 13. So now cos of CAB is cos of this angle, which is cos AB upon AC, 12 upon 13. So this is one answer. Now we have to remove cot DBA. So cot DBA, which means cot 90 minus x, DBA is 90 minus x. So which is same as this angle is equal to this angle. So it is same as removing angle BCA, cot of BCA, because these both angles are same. This is also 90 minus x, this also is 90 minus x. So in this triangle ABC, cot is what? Adjacent upon opposite. So adjacent is 5, opposite is 12. So 5 upon 12. So this, both things we could find out. Next. So this is very similar to this sum. So you can try this in homework. Let us try to do fifth one. In triangle ABC, so in this sum we have not been given the figure. In triangle ABC, AB equals to AC equals to 15 centimeters and BC is 18 centimeters. Find cos of ABC. So I have been given triangle ABC. So this is A, this is B, this is C. AB and AC, they both are equal to 15 centimeters. This is 15, this is 15. And BC is 18 centimeters. I have to find cos of angle ABC. Now if you see, if I have to find cos of angle ABC, to apply the formula of cosine, sine, tan, I need a right angle triangle. But here it is not a right angle triangle, it is basically an isosceles triangle, which is not a right angle triangle. So what I will do is, I will construct here one figure. I will drop a perpendicular from A to D. Now, since this is 90 and this is 90, we have seen in triangle theory that this side is equal to this side, this is a common side, and these two angles are equal, which means these two triangles become congruent. If these two triangles become congruent, this side and this side will be same, equal. So if this whole is 18, this will become 9 and this also will become 9. Now cos of ABC. The cos of ABC I can find out by considering triangle ABD, because which is a right angle triangle. So cos of ABC is adjacent, which is BD, which is 9, upon hypotenuse, which is 15. 3 से कर दो divide, 3 by 5 is the answer. Clear? Question number 6. In the figure given below, ABC is an isosceles triangle. BC is 8 and AB and AC is 5 centimeter. Find sine B, tan C. So it is very similar to the fifth sum which we did. So you have to draw a triangle, drop a perpendicular. They both become congruent. So you get two right angle triangles. Whatever has been asked, use the cosine, sine and tan ratios and then find that out. Let's try to do seventh one. Seventh one is in a triangle ABC, triangle ABC, this is 90 degrees, B is 90 degrees, CAB, this is given as x degrees, tan x is given as 3 by 4, BC, this is 15 centimeters. Find the measures of AB and AC. Okay, let's try to do that. Now tan x by definition is opposite upon adjacent, which is BC upon AB. BC is 15, AB we don't know, right? But this ratio which has been given tan x as 3 by 4, so I can put 3 by 4 here. Correct? Which means AB if I take here and this if I take there, so 15 into 4 upon 3. This you get cancelled, so AB becomes 20. So that I could find this out as 20 centimeters. Correct? Now I have to find AC. So AC is very similar, like we can do Pythagoras theorem. 20 square plus 15 square is AC square. So 400 plus 225 is AC square. 625 is AC square, which means AC is square root of 625, which is 25 centimeters. Correct? So eighth one looks to be an interesting problem. Let's try to solve that. So there is a figure which is being given. Let us first try to draw the figure and then we'll understand. Let us first draw the figure. This is 90 degrees. This is 90 degrees. This is given as phi. Then this is drawn from here. This is A. This is B. This is C. This is D. This is 14. This is 13. This is 12. Okay. So now this is what the figure is given as. And we have to find out the value of sine phi, and this is theta and tan theta. And we have to express AD in terms of theta. Let's try to do that. So sine phi is very simple to find out, because if you take a triangle BCD, it's a right angle triangle. So we'll use sine phi as opposite upon hypotenuse. But opposite we do not know. We do not know the measure of CD. So how do we find that out? So in triangle BCD or BCD, we can use Pythagoras theorem. So we know now the Pythagoras triplets very well. So every time I'm not going to do AB square plus BC square is AC square. So let us try to do 169 minus 144 is 25. 25 ka square root is 5. So this is going to be 5. So sine phi becomes opposite upon hypotenuse, which is 5 by 30. So we could find sine phi. Now we need to find tan theta. So how do I find tan theta? For finding tan theta, I need a right angle triangle, but this is not a right angle triangle, right? So I need to construct something which becomes right angle triangle. So I will extend this here and I'll make a drop 90 degree. Clear? So now with this, now since this became a rectangle, so since this is a rectangle, if this is 12, this also is 12. This is 14, this is 5. So this will be 9. Now I can find, so I extended this here, we did this here. Now if this entire thing became 90, so if this entire thing is 90 and this is theta, so this balance thing will become 90 minus theta. Now in this triangle AD, suppose I put this as E. ADE. If this is 90, this is 90 minus theta, so this will become theta. So tan theta in this triangle, I can find it out as opposite upon hypotenuse. So tan theta becomes 12 upon 9, which is 4 by 3. Now I have to find AD in terms of theta. So in this triangle only, in AD, can I write it as sine theta? Sine theta is opposite, or let us say I will not write sine theta. I will write it as tan theta only. So let me write it as tan theta. I cannot write it as tan theta. So let us apply Pythagoras theorem here also. So 144 plus 81, 5 to 1, 225. So this becomes 15. So if I apply Pythagoras theorem here, it becomes 15 here, and I will apply now sine theta. Sine theta is opposite, that is 12 upon 15, right? Or I have to write in terms of AD. So let me take it as AD only, 12 upon AD. So AD will become 12 upon sine theta. So 1 upon sine theta, I can write it as cosec theta. So this is the answer. Okay. Let's try to see. Let's take this sum. If tan A plus cot A is 5, find the value of tan square A plus cot square A. If tan A in a triangle, tan of A plus cot of A is 5, find the value of tan square A plus cot square A. Okay. Let us see how do we do it. So now we have been given tan A and cot A. We have to find tan square A and plus cot square A, which means I need square. So I will square both the sides. So if I square both the sides, so tan A plus cot A, the whole square, will become equals to 5 square. Now A plus B, the whole square, I will apply that formula. So this will become tan square A plus cot square A plus 2 tan A cot A is 25. Now tan square A plus cot square A plus 2 tan A. Cot A, can I write it as 1 upon tan A because it is reciprocal of tan A. This will get cancelled. So tan square A plus cot square A, 2 I will take on that side, to 25 minus 2. So tan square A plus cot square A is 23. Understood? Next, let's try to evaluate 14th sum. What does 14th sum say? In a triangle, 5 cos A minus 12 sin A is 0. Then I have to find out the value of sin A plus cos A upon 2 cos A minus sin A. Correct? So I've been given this 5 cos A minus 12 sin A is 0. So let's try to see how we can modify it. So I can write it as 5 cos A as 12 sin A, which means I can take this down. So 5 is 12 sin A upon cos A. Now I'll take 12 here. So 5 upon 12 is sin A upon cos A is tan A. If why sin A upon cos A is tan A, I'll make you understand. Suppose this angle is theta. This is P, this is B, and this is H. We know that sine theta is P upon H, P upon H. Cos theta is B upon H, and tan theta is P upon B. So P upon B, can I write it as P upon H upon B upon H, because HH will get cancelled. P upon H is nothing but sine theta, and B upon H is cos theta. So that's why sine upon cos is always tan. So 5 by 12 is tan A. So I will construct a triangle now. This angle is A, this is 90. Tan A is what? Opposite upon adjacent. Now this is a right angle triangle. So if I do the Pythagoras theorem, this will come out to be 13. Now I have been asked to find out this value, sin A plus cos A upon 2 cos A minus sin A. So what is sin A? Sin A is opposite upon hypotenuse, which is 5 upon 13. Cos A is adjacent upon hypotenuse, which is 12 upon 13. Upon 2 into cos A, which is 12 upon 13, and sin A is 5 upon 13. So if I add this, 17 upon 13, 24 minus 5, 19 upon 13, 13, 13 will get cancelled, 17 upon 19 is the answer. Okay? Yeah. So you see how basically, if you understand the basic definition of trigonometric ratios, it becomes very, very simple. And if you know the basics of triangles and quadrilaterals, Pythagoras theorem, then all these problems are very, very simple and easy to solve. I do not know why you guys get so feared about trigonometry. I guarantee you that once I solve all these problems, you won't have any issue in trigonometry. You need to go through this entire series of lectures which I'm going to give, and I'm going to post on my YouTube channel. Let's try to solve 15th. So in 15, they have given us a figure. What does that figure say? This is 90. This is D. This is A, and this is C. This is B. This side is equal to this side, as this is the midpoint. We are asked to find out tan of angle CAB upon tan of angle CDB. So CAB, which is this, and CDB, which is this. So let us say I will mark this angle as x degrees, and I will mark this angle as y degrees. So can I say I've been asked to find out tan of y degrees upon tan of x degrees? Clear? So let us say this side I will take it as k. So this also I can take it as k because they both are equal. Now what is tan y in this right angle triangle ABC? Tan y is opposite upon adjacent, that is BC upon AC. So this I can write it as BC upon AC. And tan x I can write in this triangle, right angle triangle, as BC upon DC. Correct? So this BC and this BC will get cancelled, and now this DC will go up, DC upon AC. So what is DC? DC is K, we had assumed. And what is AC? AC is K plus K, 2K. K gets cancelled. Answer is half. Same way you can find out tan ABC upon tan DBC. Let us try to do that. Tan of ABC, which is this angle. So tan of ABC is this upon this, opposite upon hypotenuse, which is AC upon BC, upon tan of CDB. So CDB. So CDB. So this is what we need to find out, which is BC upon BC. Correct? CAB, or it was ABC upon DBC. Sorry, they asked DBC. So what is DBC? DBC is this. So this and this 10 you have to find out. So this will not be BC upon DC. This will be CD upon BC. CD upon BC. So this BC and BC will get cancelled. So it will be AC upon CD. AC is 2K and CD is 1K. So this will become 2. Okay. Next sum. Oh. Let's try to do 17th one. In triangle ABC, so let's try to draw so that in triangle ABC, this is a 90 degree angle. This angle is B, this is A, this is C. That is 90, B is 90. Tan A is 0.75. So tan A is given as 0.75. And AC, this is given as 30 centimeters. Find the lengths of AB and BC. Very good. So see, tan A is given as what? 0.75. Can I write it as 3 by 4? Because 3 by 4 is 0.75. Or if you don't understand this, I can split this as 75 upon 100. 25 3s are 25 4s are. So this is 3 by 4, which means this is 3 and this is 4, because tan is opposite upon adjacent. But now this is appearing in terms of ratio, and this actually has been given in terms of actual quantity 30 centimeter. So how do I find that out? So let us try to understand. So let us say, can I assume this as 4x and this as 3x in actual quantity, and I apply the Pythagoras theorem. So this will be 16x square, this will be 9x square, should be equals to 30 square, which means 256, no, 25x square equals to 900, which means x square becomes 900 upon 25. So this will be 25, 3s are 75, 150, 36. So x square is 36, which means x is square root of 36, which is 6. So x came out to be 6. So this would be 3 into 6, which is 18, and this will be 4 into 6, which will be 24. So sides BC and AC are 18 and 24. So you understand one thing, when the ratio is 3 by 4, it is the lowest ratio. So the side lengths would have been different. So उसके लिए हमको क्या करना है? If 3 upon 4 is there, then we consider the sides as 3x and 4x, because ratio always would be 3 upon 4. And then we applied the Pythagoras theorem, and then we can find the value of x, and then we can find the value of 3x and 4x. That's how we got the sides. Okay? Next. Let's try to solve 20th. So, in triangle ABC, AD is perpendicular to BC. So let's try to consider a triangle ABC. So this is A, this is B, and this is C. And they've said AD is perpendicular to BC. So AD is perpendicular to BC. Sine B is 0.8. So sine B is 0.8. BD, that is this, is 9 centimeters. Tan C is 1. Find the lengths of AB. So we have to find AB, AD, AC, and DC. Okay, let's try to find out. So let's start with what is given to us. Sine B is 0.8. So can I write sine B as 8 upon 10? as 4 upon 5. So in this triangle, this is 90, so this also is 90. So sine B is opposite upon hypotenuse. So it is 4 upon 5. So can I say it is 4x and this side is 5x? I can say that? Very good. Now, and tan C, we'll figure that out later on. So here, in this particular, so tan C is given as, so let us find that out also. So tan C is given as 1. So what is tan C? This upon this, and since it is 1, DC also has to be 4x, because 4x upon 4x only will be 1. So because this is AD upon DC. So if DC is 4, AD is 4x, so for this to be 1, DC also has to be 4x, right? Only then it will become 1. So now I got all the sides in terms of x. Now I can find out everything. In this particular triangle, I will apply Pythagoras theorem. So what does Pythagoras theorem says? 4x square plus 9 square is 5x square. Correct? Which means 16x square plus 81 is 25x square. Which means 81 equals to 25x square minus 16x square. So 81 equals to 9x square. Which means x square is 81 upon 9. Which means x square is 9. Which means x is square root of 9, which is 3. So the value of x came out to 3. So which means this will be 4 into 3. So this side is 12. This will be 5 into 3. So this side will be 15. This will be 4 into 3. So this side will be 12. So we could find this side, and this side. Now this side is remaining. So for this side, we'll apply Pythagoras theorem here. So Pythagoras theorem is what? 12 square, this square plus this square is AC square. So 2 times 12 square is AC square. So which means AC will be square root of 2 into 12 square, which will be 12 root 2. So this is the answer. So this will become 12. So we could find all the sides that have been asked to us. Next. Let's try to do 22nd sum. Okay, let's do 21st. It doesn't have any, it has variables in terms of Q and P. So let's try to find it out. So it is given to us that Q tan A is given to us as P. Find the value of P sin A minus Q cos A upon P sin A plus Q cos A. Okay, this is what we have to find out. So let's construct the triangle. This is angle A, this is 90. So what is tan A? Tan A will be, if I take Q down, P upon Q. So what is tan A? Opposite upon adjacent, so P and Q. So if I do Pythagoras theorem, won't this hypotenuse will be square root of P square plus Q square? Correct? I don't need to go into details of how this came, because we know Pythagoras theorem, so it will be square root of P square plus Q square. So what will be P sin A? In this, I can write P. What is sin A? Sin A is this upon this, that is P upon square root of P square plus Q square minus Q cos A. Cos A is what? This upon this, that is Q upon square root of P square plus Q square. Now, P sin A, again P into P upon square root of P square plus Q square plus Q into cos A is square root of Q into P square plus Q square. Now if you see, this entire thing common on denominator will get cancelled out. So what will be left on top? P square minus Q square in numerator and P square plus Q square in denominator. So this is the answer. Okay. Let's try to figure out 24th. So in 24th, what they have given? They have given 2 sin x is root 3. So 2 sin x is equals to root 3. Evaluate. First is 4 sin cube x minus 3 sin x. So let us find out this first. So from this, what will be sin x? Sin x will be root 3 upon 2. I'll take 2 down. So what will this become? Sin cube x, that is root 3 upon 2 the whole cube, minus sin, that is root 3 upon 2. So this will be 4. Root 3 cube is 3 root 3 and 2 cube is 8, minus 3 root 3 upon 2. So this 4 will cut with this 2. So 3 root 3 upon 2 minus 3 root 3 upon 2 is 0. So the value of this is 0. What's the second thing that they have asked? They have asked 3 cos x minus 4 cos cube x. So now I'll have to find out cos x. So I'll construct the triangle. No? If this angle is x, this is 90. Sin x is root 3 by 2. So sin is opposite upon hypotenuse. Now I need to find out this value. Let us say a, b, c. So I can say ab square plus bc square is ac square. AB square is root 3 square, which is 3. BC square I need to find out. AC square is 2 square, that is 4. So BC square is 4 minus 3. So BC is 1. So this is 1. So cos x will become adjacent upon hypotenuse. So 1 upon 2. 3 into 1 upon 2. Minus 4 into 1 upon 2 whole cube. So 3 by 2 minus 4 upon 8. So 3 by 2 minus 1 by 2, that is 2 by 2, that is 1. So this value also we can find out. Next, let us try to do question number 28. What have they asked in that? So they say, question says 5 cos theta is 3. Then you need to evaluate the value of cosec theta minus cot theta upon cosec theta plus cot theta. So very simple, we have been given cos theta as 3 upon 5, because if I take 5 down, then I'll construct a triangle. Cos theta is what? Adjacent upon hypotenuse, so this becomes 3, this becomes 5. By Pythagoras theorem, this side will become 4. Now cosec theta, what is cosec theta? Cosec theta is hypotenuse upon opposite, so this will become 5 by 4. And what is cot theta? Adjacent upon opposite, which is 3 by 4. And here it is 5 by 4 plus 3 by 4. So here it will be 2 by 4 upon 8 by 4. 4 will get cancelled. 2 by 8, which is 1 by 4 is the answer. Okay. Let's go to next. So let's try to solve question number 29. So what does sum say? It is cosec A plus sin A is 5 1 by 5. You have to find the value of cosec square A plus sin square A. This is what you have to find. So since I need cosec square A plus sin square A, I have been given cosec A plus sin A, which I have to square both the sides. So let me first write it in a proper fraction way. So this I can write it as 26 upon 5. Now I will square both the sides. Is 26 upon 5 the whole square. So this will become cosec square A plus sin square A plus 2 cosec A sin A, and this will become 676 upon 25. Now cosec square A plus sin square A plus 2. Cosec A is reciprocal of sin A, so I can write it as 1 upon sin A into sin A is 676 upon 25. this sin A will get cancelled. So cosec square A plus sin square A plus 2 is 676 upon 25. I will take 2 on that side, which will give me the value of cosec square A plus sin square A, which will be 676 upon 25 minus 2, which is 676 minus 2 into 25 upon 25, which is 676 minus 50 upon 25, which is 626 upon 25, which can be written as mixed fraction as this is the answer. So I'll be continuing with more such sessions on trigonometry. I'm here to take all the efforts and try to complete the entire syllabus of trigonometry of 9th, 10th, 11th, 12th grade for all the ICSE, CBSE, ISC and A-level Cambridge boards. So do not worry at all. Thank you so much.